Hello, everyone. My name is Vlastimil, and I'm one of the developers which is working on the prototype or project we are working in the OpenNebula, and which was Ignacio talking at the beginning. This project should allow you to create cloud disaggregation. The ideas behind this cloud disaggregation is that is to enable to grow your OpenNebula clouds on public cloud providers in various data centers, possibly in centralized data centers or edge data centers. Everything should be done in a flexible, easy, and fast way. If you have any on-premises or current resources, it should be compatible across all the resources you are deploying, and at the end it should be transparent, or as much as possible transparent to the end users. Basically, it means that we are building compatible KVM clouds across various providers, starting with your on-premises resources and ending at the site of public cloud providers. So I believe most of you is running some on-premises resources, some servers. There are valid reasons behind this. You have a great control over your resources, but you probably know or are aware that the capacity of what you have in your server room or your data center is fixed. And if you need to grow your on-premises resources, you need to plan in advance. Which means there is a low flexibility on how you can grow your existing resources. We have a thing called bare metal cloud, which are basically physical servers managed or provided in the very same model we are aware from virtual public cloud. Similar API, similar pricing, and everything we like about the public cloud. And when I go back to the ideas behind the cloud disaggregation, if we have providers, different providers possibly, which are giving us a possibility to have physical resources which are sharing the same base capabilities, which means all the hosts are able to run a custom hypervisor, our preferred hypervisor, KVM. This possibility gives us the option to build a layer, virtualization layer, which is shared and compatible between all our resources. So basically, if you are able to build our KVM cloud anywhere we need, we can reuse the things we already have for our KVM cloud. We have some images, we have some templates, everything we have done already, we can run anywhere. This bare metal cloud gives us possibilities or flexibility of the public cloud. And it also gives us control over the hardware resources, similarly as to what we have with on-premises resources. Basically, we have released 2 months ago, at the end of September, some tooling which should allow to build this disaggregated cloud. It's available on GitHub, and you can install it as a standalone command line utility on your front end. It's a utility, so it's more focused on cloud administrators, not on cloud users. This utility, what we have on the GitHub as an add-on, is focused on a single use case. It can extend your current cloud with a single host, single bare metal host, in a single run, of course, on a remote cloud provider. we provide the drivers for Amazon EC2, for i3 Metal, and we provide the drivers for a bucket. When the resources are deployed, it comes some configuration phase, which prepares these new hosts as a KVM hypervisor, with some necessary configuration changes on the side of operating system. The tool also provides full host lifecycle management. So basically that means that you can power off the physical host, you can reset physical host, and at the end delete and unprovision the host. We are working on next features, and basically the main feature of what we are working on is full cluster deployment. In a single run, you can create all the OpenNebula objects, all related OpenNebula objects, data stores, virtual networks, set of hosts. And this functionality should be delivered in the next release of the OpenNebula. Few implementation details. All the tooling is provided as a single command. You are aware, I believe you are aware with one CLI, one VM, one host, and so on. So this new tooling is the very same you are used to. The new provision is done in several phases. Firstly, you deploy physical hosts on selected provider. Then you configure these hosts, basically install the KVM, configure the operating system, and at the end, if everything everything is done okay, these resources are enabled for the users. I've mentioned we have some drivers for EC2 and for some bucket, which is something very similar to virtual machine drivers, but virtual machine drivers operates on the level of virtual machines, and these drivers are slightly modified to operate on the hosts. So basically, this is also one of the reasons this utility is installed on the server or on the front end, because it shares some base code from the server. It's also integrated with the Ansible. If you are familiar with the Ansible, so we provide a set of roles and playbooks which configures the final host into the state we need to run the KVM and so on. The whole provisioning is described by a thing we call a provision template, which is a configuration in YAML format, which describes or which contains the cloud credentials, hardware configuration which needs to be deployed, how to connect the resources, and at the end, how to configure the resources. And of course, it contains a list of OpenNebula resources which will be created at the end, basically the data stores, hosts, and networks. And of course, we think how to improve this tooling into the future. And kind of ultimate goal for the future is to allow the public networking for the virtual machines which are running on cloud providers. Because this is not an easy thing. Usually you have to talk to the cloud providers. You have to agree on or allocate the public IP ranges. When virtual machine is running on some physical host, you have to assign or associate the particular virtual machine IP addresses and on the host, and basically it's not as easy. If you these are more, let's say, enterprise use cases. If you are not interested in deploying or extending your cloud in public cloud providers, you can think about this tooling, which will be available in next release, as a framework. as a framework, you can extend to for your use cases. Basically, instead of talking to public cloud, to talk to your provision servers. If you're foreman or puppet raiser, you can get resources from your provision server. Or you can manage the lifecycle of your on-premises host over the management interface. You can reset your on-premises servers and so on. And these are just the ideas how you can use this tool and extend for your own use cases. And I will give a short demo. Basically, before the start of this day, I have deployed. I've created a small provision, which is I can't use microphone, so I will show it. Hopefully. You can see I have a provision of one cluster with 2 hosts and one virtual network. I can list these hosts. I could power off the particular host I need, and at the end, I will, with just one single command, delete all the provision, which is about deleting all the resources which were created before. And let's finish it. There was more things I wanted to show you, but I'm afraid you have to continue.